review of Boolean logic, and we'll start by looking at specifically what it says in the curriculum. So it says you need to define the Boolean operators and, or, not, Nand, nor, and XOR. Okay? So let's start with just the basic ones. And, or, and not. Okay? So these are operations that started actually with if statements, right? So you can say, well, if x equals 5 and y equals 7, then you will do something with your if statement. But you learn that and in coding was not represented with the word and. It was represented with this symbol in the Java programming language. That symbol meant and, but that's what it was, right? And with or, okay, the symbol changed to this. Okay, that was the or symbol. But let's talk about what those symbols mean. Okay, what does the logic mean with and? With and, it means both things have to be true. Okay, and with or, one or both must be true. Okay? So let's apply this to an example. Okay? So I'm going to say that we have a quantity A and a quantity B. Okay? And with those two quantities, they're going to be combined with one another. So I'm going to combine quantity A with quantity B, and I'm going to say A is true and B is true. Or I can say A is true, but B is false. Okay? Or I can say that B is true, but A is false. And then the only other scenario that would come up here is that both of them are false. Okay? Now these two quantities could be combined in a question, right? Like if it's raining outside and you have to get to school, then something would result, right? If both of them have to be true, the result would be changed. If it's raining outside but you don't have to go to school, it's not raining outside but you have to go to school, it's not raining outside and you don't have to go to school, would be those combining. But what we're going to combine them with is with our and. Okay? So true and true generates true. Because according to what we just said, both have to be true. With or, it's different. But let's focus on and for a second. True and false cannot be true because both have to be true. So this generates a false. This similarly, both have to be true. This generates a false, and this one generates a false. Okay? Because both have to be true. So far, so good? Now, what if we weren't doing and? What if we were doing or? Okay? Now, the way we defined or was one or both must be true. So I don't have to have both. I have to have at least one, but I can have both for it to be true. So because these two are true, this is true. This is at least one of them is true, so it's true. This one, at least one of them is true, so it's true. But in this one, neither one is true, so this one is false. You with me so far? Okay, so now let's translate this word and into a symbol. And we'll translate or into a symbol, just like we did in coding. So in coding, and is this symbol, the two ampersands. In coding, the two vertical lines. But if we're going to express it mathematically, okay, and we're combining two, for example, two variables, okay, and can be combined by just putting the two variables together, and or can be used by using what you would call normally the plus symbol. So essentially, and looks like multiplication in regular math, and or looks like addition in regular math. Okay? Which means if we wanted to, we could put a little red dot there. That would also mean they're applied. But this means x and y are being combined with and this means they're being combined with or. You with me so far? Okay. So let's redraw this chart again. A, B. But instead, we're going to say 0 means false, and a 1 means true. Okay? So possible scenarios, 0 and 0, 0 and 1, 1 and 0, 1 and 1. So that's like saying false, 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 true, true, false, true, true. Okay? Let's combine them with and or. What will the result be? 0 and 0, 0. 0 or 0, 0. 0 and 1, 0. 0 or 1, 1. 1 or 0, 0. 1 and 0. 1 or 0, 1. 1 and 1, 1. 1 or 1, 1. Okay? So now we're using it in a more sort of digital way, sort of on-off type switches. Same as true and false, but we're just using numbers to represent it. Okay? So now we have that happening. And now we can look at this and see a pattern. The pattern is that a 1 is generated with and only when they're both true, which is what we said at the beginning. With the or, we can see a 0 is generated, okay, only when they're both false. So the thing about and or is they're kind of the opposites of one another, right? Notice this is all zeros in a 1. This is all 1s in a 0. In the two places where it was both off or both on, we can see that happening there. So there's a lot of patterns to this stuff. So now we can start putting this together and creating like algebra expressions, right? So I can say x and y or x and y or x equals an unknown value. But then I'm going to tell you that x equals 1 and y equals 0. And you could evaluate this just like you do with regular algebra. So you'd take these values and you'd substitute them into their positions. So let's rewrite it. We'd have 1 or 0, 1 and 0, or 1 and 0, or 0, or 1. Okay? Just make the ones a little bit more pronounced. Okay. So now we can use bedmass like we would normally, okay? Let's do this internal part. 1 and 0, what does that generate? 0. So 0 or 0. Let's rewrite. I know this is a bit of a redundant step, but let's do it anyways. Oh, we can do this. Let's do this right now. 1 or 0. Or sorry, that's 1 and 0. 1. Okay. So now let's do this. 0 or 0. Yes, it is. Sorry. 1 and 0 is 0. Thank you. I got to recalibrate this thing in a second, but okay. So now let's do this part. What's 0 or 0? Okay. Okay. 0 or 0? And finally, 0 or 1? 1. So now we have the answer to the question, what does this algebra generate? Okay? Now, we're going to take those two concepts again, and or, okay, which is like this. And now we're going to draw a symbol to represent them, okay? Now, as you can see, if we jump ahead a little bit in the IB curriculum, jump ahead a little bit. Oh, go away, go away. Really? Really? You're going to do that with me here? Okay. All right. go away. Okay. Right here. It says, construct a diagram using these gates, which are symbols. However, what it says about the gates is, the gate should be written as a circle with the name of the gate inside it, like this. Okay? So that's what I was talking about there. So the actual symbol in a gate for AND is just this, with the word AND inside. The symbol for OR is just a circle with the word OR inside. In reality, what I taught you in class was that the AND gate really looks like this. That's what the AND gate is supposed to look like. And the OR gate is supposed to look like this. That's what they look like. And if you put that on the IB exam, they won't mark you wrong, because these are the more accurate diagrams. But this is all they require, so you don't need to go there. Okay, so let's back up. Let's take this equation that I wrote it there. I'm going to copy it for a second. Come on. Oh, 1 sec. Okay, so we're going to copy this. Copy. Jump over to a new slide. Paste it in. Oh, yeah, that's the way we want it to work. Let's try that again. Copy, paste. Okay, so now we're going to draw the symbols for this. Okay? So we see we have an X and a Y. So the first thing is these two things are being combined using AND, which is this symbol. Now I know you can put a circle with the word in the mirror. Then I also know X and Y are being combined with an AND again. So I'm just going to take that wire, jump this wire, put X there, take this wire and connect it there. And then I think, oh, and then that is also going to be combined with Y again, right here. But now it's using an OR right here. Okay? So I've taken care of this part of it, the AND and the OR. Oh, and then I need to combine it back with the original X and Y, which I had here, with another OR. There. Now I've taken care of this part as well. Oh, and then all of that is going to be combined with X, so I need that X right here. Jump over that wire, jump over that wire. Those two things are then going to be combined with another OR right there, and that'll be my result. Okay, so that's kind of how you could draw out a circuit. Now, again, if you imagine these as wires, that's how it would get put together. Okay, so now let's see if you can go the other direction. Now I'm going to use 3 this time instead of just 2. Okay, so now I've just drawn a circuit, okay? And I'll say the result of this, A, B, and C becomes D at the end. So could I take this and write it like it's algebra, okay? Well, I got to think about what's going on. Let me switch colors here. So I know what's going on is I can see A and B are being combined with AND. So I know that's happening. That's one piece of this equation. This part here is essentially what's happening right there, A and B. I also see this little symbol happening, which is C, and I'll trace that wire back to B. So C or B are being combined. That's what's happening right here. You with me still there? Then those two things, A and B, oh wait, there's another one right here. That's an and it's taking C, but it's combining C with what came out of this. So this whole thing is being combined with another C. So I'm going to put C right there. So hang on, let me put this all together here. C is being essentially ANDed, it's like multiplying, with what was coming out of that thing. So I can actually group that together and say that's what's happening right here. At this point, it's the combination of C right there going into the wire and what's coming out of the OR between C and B. Okay? Then that result, what this thing's result is, so I'll put this whole thing into a result. That whole thing is being combined with what was happening back here with A and B. So I'm combining it, but that one is being combined with an OR, and I just put that together, and I can say that whole thing equals D. Okay? So it's another way to look at it. That one's a little more complex, but you can see there the algebra going there. Now, if I told you that this was a 0, this was a 1, and this was a 1, and I said, what's D going to be? You can do it with algebra, but you can also do it up here. And you think, okay, a 0 and a 1 go in here, a 1 and a 1 go in here. What comes out here? Yeah. So 0 and a 1 just went into it. What comes out? A 0, right. So I'm going to take that 0 and put it in over here. Now what comes out of this OR? 1 or 1. Right, so 1's going in there. And then I trace this wire back. That was right here. Oh, that was a 1 as well. What comes out of this device? A 1. So now a 0 or a 1 go in here. What comes out? A 1. Okay, so that's the way I could look at it using the devices. I could also look at it down here using the algebra. So let me just make a little more room here. I guess I can just scroll down. That works too. Okay, so this is the algebra. I'll do the same thing. I just got to remember what they are. So, 1 sec. Ah, forgot the D. Right there. Okay, so now let's do the algebra. So same thing. A or B, or A and B, or C, which is a 1, or B, 1, equals D. Okay? All right, so let's start doing this. I'll do this in part. 1 or 1 is a 1. So I have this. Yeah, like that. And I can combine these. 0 and 1 is 0. Okay? Okay, now I can say 1 and 1, 1. 1 or 0, 1, which matched up with what we had right there. Okay, so you got lots of different ways you can look at these things algebraically. All right, let's bring in the next symbol, not. Not is a simpler system because it only works on one thing. Okay, not in coding we wrote as the exclamation point. Okay. Not in algebra is often written as this little prime symbol, or sometimes it's written as an overline like that. Okay? And it's really pretty simple. So again, if I have inputs, really I only have 2 inputs, true or false. Okay? So if that's my input, the result of notting that basically inverts it. So false becomes true, and true becomes false. Okay? So it's pretty simple. Okay? So if I say to you, here's my values of x, 0 and 1, what's the value of x naught? What would you put? 1 and 0. That's right. Okay? So it reverses it. The symbol for this thing is you putting a circle with the word not in it. The proper symbol for this thing looks like this. That's the actual proper symbol for it. Okay? So if we can bring that into what we've been doing already, we can get more advanced. So I can say A naught and B, or C naught or B, with that whole thing being knotted, or A equals D. I can create a little bit more of a complex piece of equation here, okay? Now, I'm not going to draw out the symbol for it. But then what if I tell you that A equals 1, B equals 0, C equals 0, okay? Let's see if we can put this together. So 1 naught and B, or C naught or B naught or A. And instead of saying the letters, I put the numbers in their place. Okay? Now, the naught can be considered like high in the priority order. You can kind of do it first. So let's rewrite this. Let's just naught that 1. So we have 0 or 0 and 0, or 0 naught becomes 1 or 0. We'll leave that naught alone for now, plus 1. Okay? Now let's go in and work some more algebra. 0 and 0 is 0, or, okay, 1 or 0, 1. Put the naught symbol back, or 1. Okay? Let's rewrite it again. I can do this 1 naught, 0. Okay? And let's try and do this all in one step. 0 or 0, 0, or 1, 1. Okay? So the naught's not that difficult. All right, so back to the curriculum for a sec. So, where did I get lost here? Shoot. Went up too far. Went too far. Okay, I went the wrong direction. There we go. Okay, so you are supposed to define the Boolean operators and or not. I know there's more, but do you feel good about those first 3? Okay? Construct truth tables. Those tables we were drawing, those are truth tables using the above. Okay, so now we can focus on these ones, NAND, NOR, and XOR. We'll start with just these two, NAND and NOR. The N in that means not and. Okay? So NAND essentially means not and. So if we draw the and symbol we knew, like that, and we put not into it, okay, it means it's going to reverse the output. So another way you could look at it is drawn like this. But again, you do not need to worry about drawing it that way. But let's think of it in terms of the truth table that could come out of it. Okay? Because we'll go A, B, and, but then beside that, we're going to put NAND. Okay, so first of all, it can go 0, 0, 0, 1, 1, 0, 1, 1. These a little bit longer. Okay, so tell me what the ands are. No? Yeah? Right. Okay, so the NAND will be not that. So not it. 1, 1, 1, 0. That's NAND. Okay? It basically reverses the logic on it. All right. I don't think I even need to take a whole other slide for this one. NOR is the same thing. It's not or. So let's draw the table. A, B, or, and not or. 0, 0, 0, 1, 1, 0, 1, 1. First, tell me the or. Right. Shoot. No, you got it. I'm jumping the gun. There we go. All right. Tell me the not of that. Right. You got it. Okay? So it's again, you're just toggling switches on and off essentially. Okay? So now you have the NAND and the NOR. Okay? And you can see it's generating different patterns. Let's put that, so now you can see you got all these different patterns popping out here. Okay? And it leads to the final one. The final one is called XOR. And what the X stands for is exclusive OR. And what it means is it will generate a 1, or it'll be true, if one of the inputs is true, or the other one, but not both. Okay? So if we go all the way back to the original version of OR, which I told you guys. Wait, where is it? Where are you? There you are. I said one or both must be true. With XOR, the not the both part. So it's just one of them must be true exclusively. Okay, that's what it means. So, let's see if you can put that to work. Okay, so with that in mind, okay, let's draw up the table. Let me just shrink that out of the way for now. Let's draw up the table of A, B, and exclusive OR. So 0, 0, 0, 1, 1, 0, 1, 1. Yep, 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 right. You got it. Okay? So that's exclusive OR. So we'll add that to the pattern of little tables we have. So now you have, well, you have more than 3. You actually have 5 truth tables here, right? So we have AND and NAND, OR and NOR, and XOR or XOR right here for all the different truth tables, okay? Remember, the symbol for XOR, oh, I guess you can't remember because I haven't told you yet. The symbol for XOR is this. That's the math symbol for it. It looks like OR, but we put a circle around it to make it exclusive. The symbol to draw it in circuitry is just a circle with the word XOR in it, like this. But the proper symbol is, again, looks like the OR symbol, like that rocket ship, but it's got a little extra line right there. That's the exclusive OR symbol. Okay? So I can bring that into my algebra as well. So I can say, just one second. Okay, so you see this? So then I say again, x equals 0, y equals 1. What's z, right? So we could fill it in, right? We could say, okay, 0, XOR, 1, not, or 0 and y. Okay? So I can do this. 0 or and 1 is 0. Okay? I can not this, so I can have 0, XOR, 0. Okay? So it's a 0, yeah, or 0 equals 0. Final answer. That's what Z is. Okay? I could also create circuitry from this if I wanted to. So let me create some circuitry from this. And again, I'm not going to use the cop-out that the IB does. I'm going to use the actual symbols. Okay? So I'm going to have an X and a Y as my inputs. And I know, okay, well, I know Y is being knotted. So I'm going to draw a knot symbol there. And then it's going to be combined with X right here. So there it was knotted. Combine it with X using XOR. Right there, okay? Okay, I also know X and Y are going to be combined just with an AND, so I'm going to take those two, jump over, and I'm going to take my Y right here, and I'm going to combine those two with an AND. There we go. So that's taken care of. Oh, and then the answer from that and the answer from that are going to be combined right here with an OR. And I got my circuit, okay? So that's how we can put stuff together. NAND and NOR don't have math symbols that you need to know, but that's sort of the symbol sort of purpose of it. So here is again from the IB, it says you can construct truth tables no more than 3 inputs. So you know I used A and B, X and Y, X, Y, Z. It would never be A, B, C, D, E as inputs. It's only going to use up to 3. They could use something like this. Maria won't go to school if it's raining. if it's cold and raining or she has not done her homework. So you could take that and try and turn that into some sort of math logic. It's sort of like a word problem in math. Okay? All right. And then right here, construct diagrams using and or not. These will be limited to output dependent on, again, no more than 3 inputs. The gate should be written as a circle with the name of the gate inside it like that. And that's it. That's that. Let me just show you what we did in ours. So we did a lot more than that. We talked about Boolean algebra. So in the notes it talks about and or not. It has the truth tables in there. It has the actual symbols in there. It's got the same truth tables down here again showing it. It's got the real symbols. It's got more explanations about how it's got some sample circuitry built. It's got some sample problem solved here using 3 inputs. See, A, B, C. It's just 3 inputs. It's got some description of how it can get to Nand and NOR there and more complex types of truth tables. So here it talks about Nand and NOR gates in more detail and how those can be drawn out. And then it talks about exclusive OR, which you see right here, the symbols for it, all the way up to some algebra with it. And again, you can see here, this is just 2 inputs, not even 3. Okay? So that's all there. That's all in your notes. The assignment, if you want to practice, is at the bottom of that booklet. There's a thing here, number 9. Please simplify, construct a truth table, and construct a circuit logic diagram for these 3. And those are pretty complex equations. I do believe, however, they do stick to 3 inputs. So ABC, XYZ, and SPQ. And R. Oh, the last one, I give you 4. So just to push you a little bit. All right, so that's how you guys can review and study for this section of the curriculum.